Hi guys, welcome to Linux YouTube channel. My name is Ram Mishra and I am your online instructor. So what's new in this video? In this video I will tell you how to configure red mirroring in Linux. So guys, let's begin the topic. But before start the lab session, we have to understand few points, which is what is red mirroring and its use cases. So basically red mirroring means an exact clone or mirror of the same data writing to on two disk drive. A minimum two number of disks are required in array of to create RAID 1, or it is useful only when read performance or reliability is more required than the data storage capacity. Out of two hard disk drive, user will get only one hard disk to store the data. For example, suppose you have a configured software RAID 1 using two hard disk drive of size 1 terabyte each. Out of two 1 terabyte hard disks, user will get only one hard disk to store your data. This is one of the disadvantages of software RAID 1. In case one hard disk drive got failed, then you will be able to get all your data from second hard disk drive due to mirror technology. When you replace new hard disks in place of faulty one, RAID 1 will automatically synchronize the data to new hard disks from available working hard disks. So this is all about the mirroring. And if I talk about the RAID stands for redundant array of independent, or sometimes it is inexpensive disks. It is a mechanism for a logical combination of two or more disk drive to provide the fault tolerance and perform upgrades. Different architecture in which these functionalities are provided are called RAID levels. RAID levels are from 0 to 6. Here I am showing you how to create RAID 1 using mdadm command, and will show you how we can configure RAID 1 using the same command mdadm. So mdadm stands for multiple disks and device administration. It is a command line tool that can be used to manage software RAID array on Linux machines. So guys, let's begin the lab session. And as you can see that this is my Linux terminal, and currently I'm using RHEL 9. Let me show you the OS release version of this machine. So cat etc Red Hat release, you can see currently I'm using RHEL 9.0. So pre-requirement of the configure software RAID level 1 is we require at least two minimum hard disk drive storage of the same size, but you can add more disks as per your need. So in this demonstration currently I am using three hard disk storage of 5 GB in size. So let me show you with lsblk command. Here you can see that sdb, sdc and sdd, all these storage have the same size 5 GB, right? So you can see here currently I have three storage which is the same size 5 GB storage are A, SD, B, C and D. So move to the first step, which is install mdadm software package on Linux using yum or DNF manager tool. So I go with yum install mdadm, and let's see what happened once I press enter. Hey, it's already installed. So if it is not installed, you can go with the yum command or DNF command. Right, now move to the next step, which is create partitions for the software RAID 1. We need two identical partition for create RAID 1 with mdadm command. Now I'm going to create the full partitions one by one by choosing each hard disk drive using fdisk command, and change the partition ID for the boot partition for software RAID, which is RAID level. So go with the fdisk command, or you can go with the parted command, anyone. I'm going to start with the fdisk command. So I go with fdisk and go with the first one, dev sd. I go with the b first, okay, and press n for create the new partition, then press p for make a primary partition. Okay, now select the partition number. So I go with the default one, give the default full size by just pressing 2 times enter. Say go to the first sector, go to the last sector completely. Okay, now press P to print the default partition. Say I can go with the P, and you can see that this is the first partition, which is SDB1. Okay, now press capital L to list all available types. So I'm pressing capital L here. Say okay, it's already there. Okay, now I have to change the partition type. Okay, so go with the capital T. Now press capital L, and look at that, red is FD, right? So I press FD, and I got the message change type of partition Linux to Linux red auto detected. Okay, now again we use small p to print the change that we have made. So we can go with p, see it's change Linux red auto detected. Okay, now use W, save and quit. Now follow the same instructions to create new partition on dev SDC drive. So I follow the same process for SDC. Say new primary enter enter, say toggle fd and w. Okay, after creating and the save partition, we have to run the partpro command to update the partition entry in running kernel without restart the system, right? So finally we will run the partpro command to inform the OS of partition table changes. So I can go with the partpro command dev sdb, similarly for sdc. Right, now we can verify the partition entry using lsblk command one more time. So if I go lsblk command, see sdb1 and sdbc. Okay, and now I'm not currently touching sdd drive. I will go with on letter. Now our both partition are created successfully. We can verify the changes on both sdb and sdc drive using mdadm command, and can also confirm the read type. So I can go with mdadm and capital E and dev sd, and I can go with B and C. So capital E for exam the storage, right? See, look at that. The type is FD and the type is FD on both SDB and SDBC, right? Now move to the next step, which is create mirrored array. So our devices are ready. We will create read one device called dev md0 using mdadm command, right? So again go with the mdadm command and hyphen create create. Device name is dev md0, sorry, md0, and level is equal to this is mirror mirror, and hyphen read device. In my case this is read device level 2. I am using currently two devices, and device name is dev sd, and which one, say B and C, and partition is first, right? So press enter. Are you sure to continue? Yes. So basically this command will create dev md0 virtual drive from the two real block devices dev sdb1 and dev sdc1. As you can see above, software read array, the read one array started successfully. To check out the details of software read one partition, again we can go with the mdadm command with detail option. So I can go with again mdadm dev md0 and remove create here details detail detail. So once I press enter, you can see active device is 2. Currently I have sda1 sdb1 and sdc2, and active device is 2, and read level is read 1, right, which is mirroring. So we can also check one more, cat proc, go with the cat proc md status like this, say read 1 and sdb1 sdc1, right? So we can also check from here read partition 1 table entry. And now move to the next step, which is creating file system on read device. So as you know, we have configured the software read 1 and get the read partition id, that is dev partition, that is /dev md0 successfully. Now we have to format the partition and assign the file system like we do with the normal partitions, right? So here I'm formatting the read 1 partition using xfs file system. You can go with anyone, it's total up to you. xfs and dev md0. Okay, now make a mount point for partition for data storage. So go with the mkdir, I say right. Okay, for permanent mounting, just edit the /etc step file and make it permanent mount. So let me take the UUID of this read device using plkid command. So I go with plkid block device id. Hey, here's the UUID, so I can copy it from here and put up the same entry in etc step file for permanent mounting, right? So right click paste, right click paste. Okay, let me copy one more time. So select the entry from here, copy. Okay, go to the bottom, right click paste. Okay, be very careful whenever you are put up the entry in this file, it's very important. Say read and file system type is xfs, and go with the defaults condition, defaults 00. Save and quit systemctl daemon reload, and then what I need to do now, refresh all mount point by using mount -a command and check all mount point using df small h command. So av, okay, successfully mounted, you can see that. And now I can go with df capital th command if I go with all, see, look at that, Dave MD0 XFS 5.0 is 2% is in used, right? So let me create some files and verify the contents after under the mount point, right? So move to the red one and I create a file, Red Hat Linux, say I love Linux, save and quit. Let me copy some content of from boot directory from here. Okay, yeah, here it is. Let me check the content, say red and Red Hat Linux. Yep. So I copy all content from the boot directory to here and make a one file, Red Hat Linux, with some data content, right? So it is very important to save our one more last important point we have to discuss here. It's very important to save our red1 configuration in etc mdadm.conf file. So for that we will again run mdadm command with the details option and redirect the output in /etc mdadm file, right? So mdadm, go with hyphen detail and scan and hyphen verbose verbosity mode, go to the etc mdadm dot conf file, mdadm dot conf file, mdadm. Okay, let's check the entry, etc mdadm.conf file. Here it is the entry of that one. So now the above configuration file is ready by the system at the reboots and load the red devices, right? Now move to the final step, which is verifying the data after disk failure. So our main purpose is even after one of hard disk fail or crash, our data needs to be available. So let's see what will the effect happen when any of disks fail or it is unavailable in the array. So now if I check the detail one more time, again with the same command, like mdadm detail, let me remove that entry, dev md0, you can see that currently we can see there are two devices available in red and active devices are 2. Now let's see what will happen if one device plugged out or removed something or it fails, right? So let me mark this device as a fail. Say I go with mdadm and hyphen manage manage and I'm going to manage the dev md1 hyphen fail, which one, say dev sdc1. Okay, I'm marked the sdc1 as a failed device. Okay, so once I press enter, I got the message dev sdc1 fault in dev md0. To verify that the disk is failed, we can again check from the cat proc md status command, proc md status. See, it is here you can see small capital F, disk will be marked as a failed, right? And we can check it from here also, like detail, see it's faulty. Got it? Now we can remove this disk from the from dev md0. How can I remove that one? The simple, replace the fail with remove. Okay, so now once I press enter, it's hot removed. So again I can check the detail from mddev detail, see it's removed successfully. Or if I go with again with proc md status, hey, it's only one sdb1, right? So out of 2 hard disk drive, one hard disk got faulty and we removed successfully that hard disk from the software red1 partition. Now let's check 2 important things. First one is the mount point and second is the data. So if I go with the /th command, /red is still there. Alright, you can see that. And let me check the data here. Yep, data is still there. Even I can read the file also, cat, say Red Hat Linux. Yep, so we can add a new hard disk in place of 41. You can see that mirroring is still working. Okay, so let me go to the third storage, which is the dev sdd, and add in the md device. So start with the fdisk one more time and follow the same process. So I go with fdisk dev sdd. This time again go with the n primary 1 and give the full space, toggle change w, and do not forget to run the part-pro command. Okay, so now my third storage is ready to merge in red1 device. I'm going to add this disk in the place of faulty disks, right? So again I go with the same command, md the mdadm hyphen manage dev md0 and say add which one, sdd1, right? So now we can verify the details one more time with the again detail. So if I go with the detail, let me check, see, spare rebuilding, or you can go with cat rock md state. See, it's recovering 49.7, 64.9, 68.7, 76.3. So, and let me check here, spare rebuilding. Okay, and now see, earlier sdb1 and now is sdb1 plus sdd1. So if I go back again, yep, it's added, successfully added sdd1 and sdb1, and similarly if the detail md0 is there, right? So if I go back again here, I can access the data, RAID, right? Yep. So guys, this is you can see that the entry with one more time with proc. Okay, here it is. So guys, that's all about in this demo. Here we learn how to configure the software red1 disk mirroring using mdadm in Linux. I hope you enjoyed this article or this entire thing. And finally, this is the end of this topic. Hopefully you enjoyed and learned new things. Soon I will come up with another new interesting topic. Till then, keep practicing. If you feel something I have missed or you wanted to know more something else, please reach out to my social media links which is mentioned in the description. If you like this video, please do not forget to like, share and subscribe my channel and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.